So, formula 2. I have no idea what I did there. There you go. Formula 2 is proving the sine rule. Prove A over sine A equals B over sine B equals C over sine C. Is that alright? So what we're going to do is we're going to construct a triangle, generic triangle, like so. And once we construct this generic triangle, we're going to have one coming down the middle like this. Remember, sine is mainly associated, it's mainly associated with right angled triangles. Okay? So what we're going to do is this. We're going to have label them. You don't have to learn this off by heart now. You just call them A, B, and C. A, B, and C. Call this point here D. Now, what are you given? You're given a triangle ABC. Triangle ABC with sides small a, B, and C. Sorry. The angle is the big letter, the sides are the small letter. So, opposite angle A would be small a, opposite angle B would be small b, and then opposite angle C would be small c. Okay? And we're looking to prove this here. So, what we're going to do is we're going to start off with, it's a sine rule, so it's logical to start off with sine. Hey, look at Simon. So, what we're going to do here is this. We're going to say that sine A, what does sine A equal, lads? Sine A equals opposite over hypotenuse.
Yeah.
It's going to be BD over, anybody? Over C. Sine C, which is this one here, is its opposite. What's opposite sine C? BD. And that is going to be all over length A. In both equations, they have a common part in both equations. It's the BD. Let's get BD on its own. So BD equals C sine A, and BD equals A sine C. By that logic, C sine A is equal to A sine C. And which way does it want it? Alright, it wants it that way. So I'm going to bring the sine A underneath and the sine C underneath. So I'm going to have C over sine C equals A over sine A, and hence the sine rule is proven. Okay, now you will say something, a little note at the end. Okay. In a similar manner, you can write down this. In a similar manner, A over sine A can be proven to equal B over sine B. I'm going to show you how anyway. Alright? So, here's what's going to happen. See the way we use this perpendicular here? Yeah? So imagine I did it like this instead. Imagine I took out that. The point D is now gone. And instead of doing the perpendicular that way, I did the perpendicular this way. Okay? Now, it's going to happen this time around. I'm just going to rub out what we have here. Okay? It's more or less going to be the same way of doing it. Okay? And I'll just get rid of that. I proved that a second ago. Actually, wait a second. I'll just get rid of that part there. Now look at this. Okay? This time, see the angle we cut in half. Do you see the angle we cut in half? That's, sorry, I'm looking. See the angle we cut in half?
Yeah.
That's the angle you don't use.
Okay.
So I'm going to use sine B. What's sine B equal to?
AD.
Yeah, it's going to be AD over C. What's sine C equal to?
AD.
AD over
B.
B. Here, sine C, that's the opposite side, that's the hypotenuse. Okay? So what we're going to have is we're going to cross multiply and we're going to get AD on its own. AD equals C sine big, and AD equals B sine C, and you can see likewise C sine B equals B sine C, and therefore it's going to be B over sine B, C over sine C, and what we already had earlier was that, didn't we? And then you can say hence equals A over sine A. So that's your sine rule proved. Okay?